Welcome to Study Loop.
In this problem, we're given 0.200 moles of CO2, 0.1000 moles of H2, and 0.1600 moles of H2O, all placed in a 2-liter container. So the first thing we're asked to do is find, do I have a temperature here? I'm not seeing a temperature. Doesn't really matter. Oh yes, we do. We have 500 K. I knew I'd be able to find this. 500 Kelvin. Okay. So then we're asked to find the partial pressures of each of our givens. Okay. So the partial pressure of CO2 will equal nRT over V. So my pressure, my CO2 will equal N R, and let's go ahead and use atmospheres. And 500 Kelvin divided by 2.000 liters. So my partial pressure of my CO2 will equal, grabbing my calculator, 0.2 times 0.08206 times 500 divided by 2 is 4.10. And this will equal 4. Let me check my sig figs here. I believe I can go to 3 sig figs because of my 500. 4.10 atmospheres is my partial pressure of my CO2. So now my pressure of my H2 will be the same type of calculation. And the only thing that will be different will be 0.1000 moles of H2 times 0.08206 LATM per kmol times 500 Kelvin divided by 2.000 liters. And this will be half of what I had, 2.05. And then my partial pressure of my H2O will be equal to 0.160 0.08206 LATM per kmol times 500 Kelvin divided by 2.000 liters. This will be 0.16 times 0.08206 times 500 divided by 2 is 3.28. So those are my three. This is for H2O, this is for H2, and this is for CO2. Okay, now my next question is to calculate the, what else be, at equilibrium. My partial pressure of H2O is equal to 3.51 atmospheres. And then we're asked to calculate the partial pressures of everything else. So let's start with our ice that we had here. I have 4.10 atmospheres, and I have 2.05 atmospheres. This one was 0, and this one was 3.28 atmospheres. So my change at my equilibrium, I was told I have 3.51. So this will be, I'm going to change colors now. This will be plus 3.51 minus 3.28 equals be 23 plus 0.23 atmospheres. This will be plus 0.23 atmospheres. This will be minus 0.23, and this will be minus 0.23. And this will be, whoopsie, 4.1 minus 0.23 is 3.87. 2.05 minus 0.23 is 1.02. 82, my bad, and 0.23 atmospheres. So here's are the values that I'm going to use, and I'm going to have to go to the next page to use these. Let's go ahead and write our Kc expression, and that will be CO over H2O, or times H2O, divided by CO2 and H2. So plugging my values into this equation, oh, I already have this. This will be used for later. For B, my answers are my partial pressure of CO2, my pressure of H2, my pressure of CO, and my pressure was H2O was given. And this was 3.51 atmospheres. That was given. This was 3.87 atmospheres, 1.82 atmospheres, and 0.23 atmospheres. So there's my answers for B. Now we are at C and says calculate Kp. And Kp will be equal to partial pressure CO times my partial pressure of H2O, my partial pressure of CO2 times the partial pressure of H2. All my coefficients are 1. So for this, Kp will equal 0.23 times 3.51 over 3.87 times 1.82. And my Kp will equal, let me do this, 0.23 times 3.51 divided by 3.87 divided by 1.82. And I get 0.1146, and Kp to 3 significant figures, I believe, will be 0.115. Okay. Then last but not least, we have to do our Kc. And for Kc, we'll, our Kp is equal to our Kc times RT, this to my change in moles. So my change in moles equals 0. So RT times N equals 1. So KP equals KC. KC equals 0.115. We're finished.